Okay, so it's our revision and our second session on revision. We have a question on motion to quickly answer, and here it is. So we're going to run 9 marks. A forklift starting from point X. Please, you need to learn to read, and when it comes to physics, keywords are important. It's starting, all right, from point X. Needs to pick up a package from point Y, which is due east. Now, due east already tells me we are dealing with a vector quantity. That's important. What is a vector quantity? A quantity that has both magnitude and direction. Okay. Now, the package is thereafter transported to a table. Okay, so we go starting from X, we go to Y. All right, so first we pick up the parcel. Let's understand, we start from X, we go to Y, pick up the parcel. Okay, let me start from X there. Then, drop the parcel on the table. All right, which lies 350 meters due west of point X. The entire trip takes the driver 2 minutes to complete. Watch it. It takes the driver 2 minutes. Define the term average velocity in words. What is average velocity in words? I'm sure you remember the definition. We did this. Average velocity. Can somebody quickly type the definition for me? Average velocity. Quickly. Type it. Average velocity in words. I need an answer. I'm waiting. It is the rate of change of displacement. Now, that is velocity. Rate of change of displacement. That is general velocity. Anybody else? A different idea? Gift. Average velocity is the rate of change of position. Any other definition? The word average is important. What you are giving me right now is velocity. Yes, Michelle?
It is the rate of change in position when you divide the total distance over the total speed.
Total what?
Distance.
All right, okay. I'll accept all your definition, but I want us to know that we should talk about divided by the total time. Okay? Total time. All right, let's write down our answers. Number 1, average velocity. Quickly. Rate. Okay, I'll accept your rate of change of position. Okay. Rate of change of velocity, of displacement. Total displacement divided by total time. Okay, let's move from here. Number 2. So your definitions are okay. Calculate the average velocity of the forklift for the entire motion. What did you do? For the entire motion. Remember, we're saying the change of velocity. Now, what is displacement, my beautiful learners? Let me come here quickly. We have X, Y, and we have the table. X, Y, and the table. We move here to the right. And somebody's going to say, but we do not have X to Y, and then we move there, and we are told the entire duration is 2 minutes. What do we know? Velocity is what? Change in displacement over change in what? Time. Very important. Now, what's our displacement? We define displacement as what? The shortest distance from the starting point shortest distance from, check, it is from the starting what? Point. So when this object is at the table, what is our displacement? At the table. Where is this object right now? This object is 350 meters west of X. And that's our displacement. So if we take, so I'll say take east as positive, it means our displacement is negative 350. If you are not sure of what I just did, let's do this. Let xy be k, just to show you something there. Now, this object moves to the right. That is k. Moves to the left. Negative k. Then moves the remaining distance. Negative 350. If I were to add everything together, what will I get? K plus negative k plus negative 350. What's my answer? Do you notice? I still have negative 350. So I don't know if this makes sense to us. I don't know if this makes sense to us. So my velocity, average velocity, will be, we said delta x over delta t, negative 350. What is our time frame? 2 minutes. But remember, times 60. Does anybody have an answer? Get a calculator quickly. 350 divided by 2. Okay, let me show you what to do. Negative 350 divided by what? 2 times 60. Negative 2,92. And what is the negative telling you? The direction. So it's 2,92 meters per second west. Let me know if we are on board quickly. Are we on the same page? Direction is important. Okay. The last question quickly. The average speed of the forklift is 3,75 meters per second. Determine the position of y relative to x. The average speed of, remember, speed is what? Distance over time. So the average speed is 3,75. Watch this. The examiner is checking if we know the difference. Average speed. Average speed is what? Total distance over total time. When I talk about a distance, it's a scalar quantity, which means it is only positive. Okay, let's go back to our question. We said that is x, that is y, and the table. The driver first goes to right. We said k. Comes back k. And then 3. Do you notice I am not saying negative now? Because I am dealing with a scalar quantity. It has no direction. So what is my total distance? It is k plus 350. 2k. Oh, and I know my average speed. We know the formula now. We said total what? Distance over total time. And we were given the speed. What's the speed? 3,75. Do you see it? There's no direction there. Total distance 2k plus 350 over what? 2 times 60. Basic maths now. If we cross multiply, what are we going to have, my dear learners? 2k plus 350, 120 times 3,75. Let's do the math together. 120 times 3,75. It's my calculator. 120 times 3,75 will give us 450. Now, minus 350, remember? So 2k equals to 100. What is k? 50 meters. So the distance, the examiner says calculate what? Determine now, check. The position. Always read the question. Position is a vector quantity. And I see that y is on the east of x. Y is on the east. So I'll say y is 50 meters what? East. Let me know if we are good. Let me know if we are okay. So the examiner is checking for the difference between displacement and time. All right, can I quickly get on the circuit question? I'm going to take about 10 minutes of your time. You would have 10 minutes to look through, then I'll have 10 minutes to quickly deal with the question. I want to give a few seconds for writing here. Okay, there we go. 16. Oosh. All right, 16. You have try 12 minutes. Let me get you a formula page for electricity. Please don't waste time. I know that we delayed a bit, but all good. And that's my formula page. 12 minutes, we go. Hi, everybody. All right, without wasting of time, because our time is fast spent already, let's see if we can run through this in about 5 minutes or so. Okay. The circuit diagram below consists of 4 cells, which 4 cells each with a voltage of 1,5 volts. Already, guys, when I say 1,5, how many cells are here? 1, 2, 3, 4. So this is 1,5 times 4. That's how we count it. All right. Already I know my EMF is 6 volts. The resistance of light bulbs A and B are 3. A, B, and C are 3, 6, and 8. Understand what that is? 3 ohms, 6 ohms, and 8 ohms. Use the diagram to answer the question. When switch S is closed, the ammeter reading is 0,6A when that is closed. Define the term EMF. Number 1. All right, it's the maximum energy supplied by the battery. Maximum energy supplied. Just do your corrections quickly. Number 2. Write down the EMF of the battery. 1,5 times 4. 6 volts. Please mark. If the reading on V3 is 4,8 volts, okay, now we go to calculation. V3. Calculate the, number 1, effective resistance of the circuit. All right. Now, what you would notice is there are 2 types of connection here. We are going to try to combine this one first, which is a parallel. So 1 over R, can you see it there? 1 over RP is 1 over R1 plus, which is 1 over RP, 1 over 3 plus 1 over 6. If you use your calculator, what are you going to get here? 1 over 2, I think. 1 over 2. Let's check if we use our calculator. Am I right? 1 over 3. So you reduce the number of resistors. All right, 1 over 2. But we are not looking for 1 over RP. We reciprocate it. RP over 1 will be 2 ohms. Now, what I have done, my dear learners, is I have converted my resistors into 2. They are no longer 3. I've converted them, and I still have this. This is now what? 2 ohms, and this is what? 8 ohms. What do you notice? They are now connected in series. I go to my formula page. R series. R1 plus R2. 2 plus 8. And my final answer, 10 ohms. Please mark. Let me know if, give me a feedback quickly so far on question 1, 2, and 3. Quick feedback. 1, 2, 3. Waiting for Gift, Michelle, and the girls. Malaudzi, Jubo. All right. Calculate the reading on V2. Oh, beautiful. Calculate the reading on V2. Remember, I have a 0,6 volts, 0,6 amps flowing. There. Oh, so I know it's 0,6A. And because they are connected in series, I'm going to quickly do something to make it very easy for us. Look at, this is what we converted our diagram, our circuit into. We converted it into this and that. And we said this is what? 2 ohms. But the current flowing here is that. This is also that. Why am I saying that? This is 8 ohms. This is 4,8 volts. These guys are connected in series. What do we know? SAPD, South African Police Department. And what do we know about that? Series are potential dividers. What does that tell us? Current is the same. And the examiner told me to calculate V2. Again, I'll go to my formula page. Let's check on the formula page. All right? We can use, the examiner says V2. Beautiful. I'll do it in 2 ways. Check here. Because they are connected in series, my beautiful learners, I want you to enjoy circuits. They are connected in series. They take the potential difference and divide it. The total potential difference is 6 volts. Oh, so if this one has taken 4,8, remember, they are potential dividers. They split it. It means V2 plus V3 is the total EMF. So V2 I don't know, but I know V3 has 4,8, and that is 6. Oh, easy. What is V2? 6 minus 4,8, and that will give you 1,2 volts. Or we use the formula. Some of you were taught this formula. V equals to I multiplied by R. You are allowed to use it. So I'm looking for V2. It's going to be the current in 2 and the resistance there. Okay, so what do I have? What is my current? 0,6. What's the value of the resistance? 2. Check my answer. Can you see? 1,2 volts. 1,2 volts. Let me know if it's making sense. I have 3 minutes left. 2 options. V equals to I multiplied by R. So I'll go to that particular resistor and look at the voltage there. That's why for me, I always like to write what I know about a particular resistor. So I have my R and I have my I. Or I can use SAPD, series R, potential dividers. It means current remains the same. Calculate what the amount of charge that is passing through the resistor C in 20 seconds. 7.3.3. Amount of charge. What is the symbol? Amount of charge. That is Q. Passing through point C. Passing through resistor C. Let's go to the formula page. I think we were given time, 20 seconds. Beautiful. So what are we looking for? We are looking for Q. We have T. Let's go to the formula page. Which formula is Q? This is what you do in an exam. You check. All right, you check all your formulas. Q, no. No. Oh, wait. Q equals to I delta T. Current times time. Do I know the current in C? Yes. Current in C. Beautiful. So I'll write my formula. Q, I delta T. What is my current? 0,6. What is the time? 20 seconds. What will my answer be? 12 columns. Let me know if that is okay too as well. If you got that, let me know. If there is a question, we can quickly deal with it, but we're moving as quickly as possible. So always write what you have, go to your formula page and check. The last one. If bulb B fuses, that is, blows away, how will this affect the total current in the circuit? Write increase, decrease, or remain the same. I'm going to quickly help you here. Now, we no longer have B. What do we have? This is how you answer this question. B is now gone. All right? So what do we have? We only have resistor C and resistor A. No more B. What is the value of resistor A? 3. And what is the value of resistor C? 8. Okay, not a problem. The first thing you do, my dear learners, is to check what is the total resistance. And if you go back to your notes, I gave you a full table on this. Our series is what? 3 plus 8. What was the initial total resistance? If you remember, it was 10. Oh, so what happens? This is my answer. Total resistance increases because it increased from 10 to 11. But resistance is inversely proportional to current. Resistance is inversely proportional to current. Which means as resistance increases, total current will what? Decrease. And you are done. You've given the examiner more than enough. Please take note of that. And I'll just give you one last bit of note here on the resistors. Adding. Let me just give you a table quickly here to assist you on this issue of resistors. Adding a resistor in series. This is going to be total resistance. If I add a resistor in series, total resistance increases. This is very, very important. Adding a resistor in parallel, the total resistance decreases. Next, removing a resistor in series, the total resistance decreases. It's mathematics and I want you to learn it. Removing a resistor in parallel, like we did. One of them was in parallel. If you remove it, which we proved by calculation. Finally, increasing the value of the resistance, whether it's in series or parallel. I'm not adding, I am increasing the value. this one will increase. Okay? Total resistance. I'm going to end it here, but I'll give you a few minutes to write. Please, this is very, very key. Adding a resistor in series, because it's R1 plus R2 plus R3, the value is going to increase. If you add a resistor in parallel, 1 over, it's going to decrease. Then we do the opposite. If you remove in series, it will decrease. Remove in parallel, it will increase. But if you increase the value, not adding, you increase the value, instead of 3 ohms, you make it 4 ohms. The total resistance will increase. And resistance is inversely proportional to current. I hope we're good, guys. I hope we are okay. DB, you good? Awesome. All right, once you're done writing, you may please, I'm just going to wait for the last person. Please do give me a response when you're done writing. You may be excused. You may log out. Have a lovely, lovely day. Have a lovely, lovely evening, everybody. Once you're done, just let me know and just enjoy your evening. Thank you, Michelle. Good night. Namtanda, you're done writing. Awesome. All right, Lino, let me know when you're done. Awesome, Lino. Have a lovely, lovely evening too. Goodbye.